Grade 11, so what we're going to be taking a look at now is Huygens' principle. It tells us that every point of a wavefront serves as a point source of spherical secondary waves, and after a time t, the new position of the wavefront will be that of the surface tangent to these secondary waves. Now, a couple of things we have to keep in mind before we can even look at this is we have to go back to something you learned in grade 10, where you learned that when we're dealing with liquids, every liquid particle is connected to every other particle, and in your transverse waves you learned that as the one particle for instance moves up, it is connected to another particle and it's pulling that particle up, and so on and so on and so on. So when we have a point source, and that point source is making these little secondary waves. Now think of you for instance dropping a rock into water. Then on that wave front, every single one of the particles on that wave front is creating its own secondary waves, but we don't see those. What we see is that surface tangent. So that green line there is the wavefront that we see moving towards us. Okay, the next thing we also have to take a look at then is what happens when a wave moves through a small opening. Okay, so when a wave is approaching a small opening, only a few of the particles actually enter that opening, and they create their own little secondary spherical waves. Now this creates then a surface tangent, and as we can see, the surface tangent becomes a lot more straight, and that then creates that diffraction pattern that we have that enters that opening. Remembering that we learned that diffraction is proportional to the wavelength and to the slit size, where diffraction is directly proportional to the wave length and indirectly proportional to the slit size.